Welcome, software engineers, to day 26. Wow, it's nice to see you, at least virtually. As we did last time, I've asked a faculty member at Concordia University, Wisconsin, to talk to us about his experiences in computer science, in the field, with some software engineering things. I just have a series of questions that I'm going to ask him. Let me introduce him, first of all. If you're saying, oh, why does he have the same last name as you? It's because, yes, we are related. This is my number one son, who is also my colleague. It's very interesting because we teach in the same department at the same university. Students are always confused because they say Dr. Locklear, and they're not sure to separate us, but okay. So I'm going to stop that. And Josh, I'm going to turn it over to you. Oops, wait a minute. I said I was going to stop the share. There we go. Good. First of all, Dr. Locklear, would you mind introducing yourself, your background, college degrees, work experience, and any other thing you want to set the stage for?
Well, sure. Yeah. As we said, I'm Dr. Josh Locklear. I teach in computer science faculty at Concordia Mequon. My area of specialty is kind of artificial intelligence slash human computer interaction, user experience kinds of things. Those are my primary areas of interest. I did my undergraduate degree in computer science. Should I tell you how long ago that was? Yeah, I graduated 20 years ago this year, as a matter of fact, in 2002 from Concordia Mequon. Got a Master of Science in Information Technology in 2012, also from Concordia Mequon, and just finished my doctorate, my PhD in General Information Technology this year from Capella University School, primarily online, that's based out of Minneapolis. Work experience, I've done a number of different things. When I first got out of school, of course, that was in the mid 2000s. That was kind of when there was a little bit of a tech downturn. So for a couple of years, I did a number of things. I did a stint in retail. I eventually got into IT. I did user support for over a decade with a company that changed names a couple of times. We started off as a Catalyst International, eventually became CDC Software, and then a division of Aptia and both other larger companies. We made warehouse management software. We had a number of clients whose names you would have known. One of our biggest ones was Sony Music Entertainment. This was back just before kind of everything went all digital. So Sony Music, all their DVDs, Blu-rays, movies, their video games, everything got shipped out of warehouses that was running our software. So that was kind of cool, as long as the software was working. I started off doing user support, eventually ended up as a team lead, moved up, kind of ended up as a support manager over a number of years, got to work mostly in support, a lot of database work, some working with users and some interfacing with programmers in terms of support and modifications and things like that. Did that for 11 years, and then in 2015 I came to Concordia Mequon full time as faculty in the computer science department, and I've been teaching there ever since. They haven't gotten tired of me yet, so.
Thanks, Josh. Couple questions about what it was like for you working in the industry. So what was working in the software industry like for you?
It was very interesting. It was always something different. That's kind of the world of support in general. It's new things every day. Some, you've got your standard support tickets. Everybody who's ever worked in IT help desk knows that you've got some things that come in all the time, and then you've got other things that are new or unexpected, or new things get installed and software gets updated. It's the same thing everywhere. Whenever you update software, things break, but it was a good experience. It could be definitely fast paced at times. Working in a team environment, especially when I became a lead, kind of responsible for both the first line support, so kind of the people who would triage the calls, take care of the relatively simple or quick fixes. More serious calls would then have to get escalated to our second line support, so making sure that that transition happens smoothly. more serious problems if or if systems are down or things that required modifications to the software, then would have to go to what we called our tier three, which were actually our programmers. We had some programmers who were actually part of support who would work on fixes and the more detailed troubleshooting. So it was a lot of interpersonal work actually, as much as anything else, and getting to know all the people on the team and being able to talk to other people was certainly a plus, as well as having kind of the technical knowledge and a lot of database work. So it was interesting. It was fast paced. It was being on the inside of a tech company throughout the late 2000s and early 2010s. There's always fluctuations and ups and downs, and so it was kind of interesting to see some companies were better positioned for changes that came about by the advent of e-commerce than others. Our company was kind of caught flat-footed a couple of times. We could probably talk about that a little bit with some of the other questions, but it was an interesting experience. I think it was important to do that, even though my ultimate goal was always to teach. It's important to have that real world experience so that it's very easy in academia to kind of become isolated from that. And I think it's important to have that perspective because that helps students understand what's going to go on in the real world when they get out there. So.
Yeah, good. And I appreciate you saying that. And I think I shared this with my students at Irvine here, that one of the things I like about our faculty at many of the Concordias is we all have some relevant work experience in addition to the academic background. So, Dr. Locklear, what do you wish you knew before getting your first job?
Well, the number one thing would have been to start looking for a job earlier. This is, I'm going to sound like a broken record. I know everybody's been telling you guys this, but it really is true. If you wait till graduation, if you wait till senior year to start thinking about these things, it's going to be too late, at least if you want to get something that you want relatively quickly. Job hunting is really about who you know. It's really about connections, who knows the skills that you have, who you've been able to demonstrate your proficiencies to. So thinking about this earlier, thinking about getting an internship early on, sometimes we target that junior year, but even we've had sophomores do internships and be successful with that. So you need to think about early on what you might want to get into, develop connections, ask your faculty members who they know, see if you can cultivate other connections in the field, get an internship. That would really be, I think, the biggest one, because you develop connections both inside a particular company, hopefully a little bit wider than that company. And it also gives you an idea of, is this the kind of thing that you really want to do all day? Sometimes, especially in software engineering, our perceptions of what a job is going to be like are a little bit different than what it actually is. But number one thing, start early, think about this, look for an internship, look for ways to connect with people, interact with people. That is the number one thing that I would say.
Good advice. Let's step back a moment, sort of a two-part question. As both an academic and as somebody who's worked in industry, what concepts or theory should a computer science student know before leaving school?
I think the most important thing is to understand, especially if you want to be a developer, concepts of programming. Not so much a specific language. I mean, a lot of times people say, what's the hot language that you want to learn? And you look at all the rankings, and it seems like there's some variation of Python, Java, C Sharp that usually shows up at the top of all the rankings. And certainly, learning a particular language is not going to hurt you, but I think it's good to look at the big picture, look at the concepts underlying the languages. And I think that's one reason why a university like Concordia has advantages, because it's not just here, memorize, this Python cheat sheet that has all the commands that you need to do X, Y, and Z, but then you don't really learn how to put X, Y, and Z together into a program. You don't learn how to think about new or different applications. It's like memorizing the sheet music versus really understanding musical theory and how to approach a particular piece. So I think concepts of programming, not just a particular language. Many employers that I talk to or that I interact with don't even care if you know a particular language. If you've learned one language that's kind of in the ballpark for what they use, they're willing to train you, and they know that if you've got some of the background, you're able to pick up the specifics of a language. So I know nobody seems to like the theory classes where you talk about the higher level stuff. Sometimes those get a reputation as kind of scary, but those are the ones where you'll really separate yourself from somebody who goes and does, the 12-week programming boot camp that you see advertised everywhere. Certainly you can become a competent programmer that way, but you're not going to be adaptable. You're not going to be able to change when the next big language comes around or the next hot methodology. So theory, understand the concepts. Don't fall asleep or skimp in the theory class, because that's really where you're going to set yourself apart.
Good. So related to that, what skills or practice should a computer science student have before leaving school?
I think the number one skill is actually the ability to interact with people. And that sounds a little funny to say. I mean, 10 years ago, everybody would have kind of poo pooed that. But I think now, with some of the changes that have happened, it's important for you to, number one, be able to get a job that's going to require you probably to network, to interface with people, to convince people that you have skills and knowledge. And if you can communicate technical concepts to another human being, that's something that a lot of people are looking for. You're doing software development. You're going to do software development as part of a team most often. You might end up, on an island or as a department of one. But even then, you're going to have supervisors, or you're going to have QA people or others that you have to talk to. It is challenging in computer science, even when you're talking to somebody else who's well versed in the subject, because a lot of the vocabulary, the concepts are very specific. You really do have to have a good grasp of communication. The other thing that kind of goes along with that is work on your presentation skills. When we have you do presentations in classes for projects or senior projects or things of that nature, that really is meant to prepare you for the real world, where you might have, 15 minutes to sell the CEO, who's not the most technical person in the world, on your idea for a hot new mobile app. And you need to be able to explain these technical things in a way that makes sense, in a way that the CEO can understand and see the value in it. Of course, you should know, programming. You should be familiar with hardware a little bit. It's always an advantage, even if you're going to be a software person, to be able to troubleshoot things when they show up. If you don't have to wait for your own internal support to fix individual problems, or if you end up working from home with your own equipment, possibly, it's very helpful to be able to know your way around that a little bit. But people skills, I think that's the number one thing.
Nice. So, Josh, why did you decide to major in computer science?
Well, that's kind of an interesting story, because I'd been around computers all my life. Dr. Locklear, the other Dr. Locklear, it's funny, we talk about distinguishing ourselves. I always tell the students, you have to see us. Okay, you can see one of us has more gray and one of us has less gray, and then you can tell us apart. But the other Dr. Locklear, much too modest to tell you this, but he was a big deal at Hewlett Packard in the 1980s. Hewlett Packard, of course, not really as famous as they once were. They were a major player, right alongside IBM and all those others. And especially when it came to printers, laser jets, we used to have, horrible dot matrix impact printers, and laser jets really revolutionized that. Dr. Locklear was a manager in the LaserJet fonts program when the words of Ron Burgundy, kind of a big deal. But just being around the technology always made me very interested in it, to see the applications. And yeah, when you're growing up, it's all about the video games that kind of gets you interested. But seeing the application, seeing all the different things you could do with it, it's kind of cool and futuristic. And then later on, as time goes on, just the intricacies of programming and the opportunities for really creating new things and exercising human creativity. problem solving, it's always something different. If you're looking for something that's not going to be the same old routine all the time, computers are the place to be because there's always going to be a new problem to solve or a new issue to deal with. So it's kind of been, I guess you could say, a lifelong thing for me.
Yeah, good. So, 4 questions about computer science. Why is computer science fun?
I think it's just because you get to do different things. You get to create in a way that very few other people really get to. As you look in the Bible, you look at the first couple chapters of Genesis, and you see God's creative process, how He creates the world out of nothing. Now, certainly human beings aren't able to do that, but I think programming is maybe as close as we can get to that because you have your tools that you use your computer, but when you write code, even if you're taking other examples and tutorials and putting them together in new ways, you're creating something new and unique that didn't exist before in that way. I think it's similar in a lot of ways to an artist creating a painting out of a blank canvas, or a musician creating something. Of course, it's a little different, a little bit more technical kinds of things, but I think the possibilities for creation are very, very interesting as you get into it. And as I said before, it's always different. It's something new. When you're a software engineer, very often you'll have new projects, even if you're working with the same type of software. You'll have new versions. You'll have opportunities to improve on things that went before. So along with the creativity, it's the different. It's not your stand at the check people out from 9 to 5 in the retail store every day. That's for sure.
So, on the flip side of that, why is computer science hard?
Well, computer science is hard because it is different every day. And the problem that you solve today, well, that's solved, but then a new one is going to rear its head tomorrow. And then it's interesting when you look at the complexities of computer programs, as human beings, we seem to tolerate a lot more issues with technology than other sorts of things. If I had to reboot my car as many times a day as I have to reboot my computer, that wouldn't go over very well. But programming is so intricate, so complex, so many lines of code are required to do all of these amazing things. It is difficult to create perfectly and then unraveling that later on, trying to figure out why something doesn't work, uh, absolutely can be a challenge. So some of the strengths and the ability to execute large programs quickly, those also contribute to the challenges. It's going to be different problems. Debugging is a little bit hard and it get a little bit tedious. So I think those are the primary challenges that I usually see.
So, why do you find computer science fulfilling?
Well, in my current role, especially as a professor, I like being able to interact with students. I like kind of that journey of discovery as somebody goes from either not having a lot of knowledge of computer science or kind of the basic. Some people come into the intro classes and maybe they've done some programming in high school, or maybe they're coming in pretty new to it. Whatever their level of experience is, as we introduce, the concepts and all the grand ideas of computer science, to kind of watch that as the knowledge develops and increases. It's very interesting to see. Uh, Computers are great tools for serving other people. In computer science, we talk all the time about we solve problems for people in other domains. There's not really problems in computer science. There's problems in business that we solve with computers, or problems in healthcare that we solve using computers. And I think that's another aspect as well, the opportunity to fulfill our vocations. As Lutherans, we know that whatever we do, as long as it's not inherently immoral, is a calling from God, a means by which God helps us serve our neighbor. And especially with computers, many people have no idea how computers actually work, and they're reliant on those of us who do know how computers work to create good things, to not exploit people's lack of knowledge of computers to create things that aren't very good or don't actually serve user needs. I think those are some of the areas that I find particularly interesting.
Good. So, the flip of that, what is frustrating about computer science?
Mm. It's frustrating when people don't really understand how technology works because then their expectations, it's very difficult to manage. Thinking back to my time in the industry, it's sometimes very difficult to explain to a user on the phone who's got a truck waiting at the loading dock and they can't get it out because their warehouse management software didn't finish the shipment and send the information to USPS or whoever. It's very hard for them to understand. Well, why can't you fix this now? So if you don't have at least some understanding of things on the back end, a little knowledge of how databases work and some of the things involved in that, it is difficult to really explain adequately to people how this works, and that causes a lot of friction. We have all the jokes in the IT industry about user equals ID 10T errors, and problem exists between keyboard and chair. But a lot of that results from the fact that computers are difficult to understand, and it is hard to bridge that gap. Plus, technology as tools created by imperfect people is imperfect, and it doesn't work occasionally. And that's magnified with technology because it is so powerful. When it works really well, it's really advantageous. When it doesn't work, it can be a serious problem. So those are, I think, a couple of the challenges. Plus, just keeping up with new things. It's changing all the time. Now, I sometimes pick on my friends in the history department here. I tell I love history, but you're not rewriting your introductory history class every single year. Sometimes new discoveries come up, but my AI classes, I just told my students today, I have to do at least a review pass every year on those courses because it changes so quickly. So you really do have to commit to keeping up with things after you graduate. You'll have to continue to keep abreast of new developments.
Great. So this is a course in software engineering, and you've been involved with that. What do you think is more important to software engineering? Is it having good people, or is it having a good process?
Oh, that's a hard question. I've been thinking about that one a lot. If I had my choice between those two, I would say good people. Uh, Not to turn this into IT industry story time, but good people can overcome problems with process. Now, of course, an ideal world would be you have good process and good people, and then stuff usually flies pretty well. In my experience, process, while it's important, if you don't have good people in place, process isn't really going to help you. It might help to mitigate some problems, but if your people aren't up to snuff, uh, I don't want to say your process is irrelevant, but it's definitely going to be difficult to create anything worthwhile. So, short answer is both. If you force me to pick one, I'd say good people. And if you're looking at an organization to get into, the number one thing to look at is the people, how they interact with each other, how you interact with them, how they interact with their customers. People, I really think, are the key.
All right, good response. So Irvine and Mequon, we are Lutheran Christian universities. Can a Christian worldview affect the job of computer science and software engineering in a positive way?
I absolutely think so. I mean, in the world of technology, if you know how to use computer, you wield power. You wield real power, and using that power responsibly is very important. One of the examples that I always tell my students about is just look at all the controversies surrounding virtually all the big tech companies today. You look at things like Facebook. We all know what's been going on there with questions about algorithms and how they restrict information. Twitter, kind of the same sorts of things. Even Amazon, how it leverages its influence in various realms. The leaders of all those companies do not have Christian worldviews. And you see that this comes out in some of the things that they get caught up in. I think having a Christian worldview helps you, number one, navigate these ethical issues because you don't have a solid framework for your ethics unless you have an absolute source for them, i.e., God. And it also helps to restrain sort of the natural human inclination to take advantage of people, to use your knowledge for your own benefit. Just a real quick side thing, I've been thinking about how to connect this more closely to scripture. And if you look in the Old Testament, in multiple places, God will chastise the Israelites for false scales. This happens more than once, where he says, you have false scales, and of course, in the context of biblical times, that's weighing out, however much you're going to pay. If you're 1 pound weight, you're going to pay 1 pound of gold or silver for something. Well, if that 1 pound weight is labeled something else, and that person doesn't know, they don't know how the system actually works. Well, now it's very easy for you to take advantage of them. Computers are kind of like that for a lot of people. Computers are a black box. People will by and large take your word for how they operate, and you have a lot of opportunities to manipulate them for that's practically what it comes down to. So creating a system that is fair, even when there's opportunities for you to easily make it unfair in your favor without people catching on. I think the Christian worldview is really the best way to address that particular problem.
Thanks. So for students, what is your perception of what the job market is like right now for computer science graduates?
Well, I think that technology jobs, you're still in better shape than a lot of other things. Of course, it's hard to tell what's going to happen tomorrow with everything, that's going on. The job market is always kind of like that. You see things like, Amazon lays off people and Facebook lays off people. Those, I think, don't really have to do with technology. That has to do with kind of a lack of vision or incorrect vision at the top of the company. But everybody needs people who know computers. So will you get into exactly the company you want? That's kind of hard to say. Will you find somebody who needs a computer science graduate who has programming skills, IT skills, technology skills? That is probably going to be a little bit easier. Those types of skills are still in demand. Demand's just going up. People are computerizing more and more things. So uh, again, hard to say exactly what the future holds, but I think technology graduates, you're probably in some of the best shape of any of the graduates out there right now.
Good. So what's your advice? How would a new graduate go about getting a job?
Well, the number one thing is know people, meet people, get your name in front of people, network with people. Everybody wants to focus on job skills and certifications or specific pieces of knowledge, and that's certainly important. But you need to know people who you can demonstrate these skills to, who you can interact with. There's lots of people out there who are graduating with computer science degrees, and if you want to stand apart, developing personal relationships is really the way to do that. Thinking, at our campus, we require internships, and it's not 100%, but very often the internship will lead to employment for the student, or it leads the student to kind of say, well, this internship, that wasn't quite what I thought it would be, so I'm going to look at another way, and that's advantageous as well. Then you don't end up in a job that isn't well suited to you. But meet people, talk to your professors, see who they know in the industry, talk to classmates, talk to people who are in the industry. If there's any type of networking events where you can go to technology related things and meet people and get your name in front of them and talk to them, that's the number one thing, I think, is to get your name out there and talk to people.
Good. Do you think there's any advantage to going on to graduate school for a computer science major? Should a computer science major think about a master's or even a doctorate?
I think it can be, but I really would encourage people to kind of think about your long range career goals before you do that. As a person who just finished graduate school this year, I could tell you, do it if you think you're going to need it for your career. Computer science is something where I definitely wouldn't say do a graduate degree just to do a graduate degree. I don't think it's necessary in all cases. But if you think that you might want to get into management, for example, maybe you don't want to be the coder a whole day. Maybe you want to be the manager in charge of development or in charge of teams, or maybe, eventually a CIO or something like that. Then I think a master's degree does have a lot of value. In terms of a PhD, unless you're looking to teach, or if you want to be, maybe a very high C-level executive. There is some call for that sometimes at the CEO level and stuff. PhD is, well, it's kind of a different thing. So if your career path demands it, you should do it. And I would encourage you, if you think your career path needs a graduate degree, do it as soon as possible. I know that's not what you want to think about. You're already doing enough years of college and you want to be done and you want to move on, but take it from somebody who didn't do that, who did his graduate degree with work and family responsibilities. It's not the ideal way to do it. Think about your career, do a little looking, ask people in the field. If you think a graduate degree is going to benefit you, go for it. But if your path, it doesn't look like it's necessary, then don't do it just to do it.
Wonderful. Last question. And students, after this question's answered, if you have any questions, feel free. I'll give you an opportunity. You can unmute or post something in chat. So what are your words of wisdom for right now for a student? How do I survive and even thrive in computer science classes?
The number one thing that I say to students is manage your time. And this really applies, I think, to everyone in every job everywhere, but especially in computer science. The things that we do tend to be a little bit more complex. You might have noticed programming classes tend to be harder than a lot of other types of classes you might take. There might be a little bit more work or the projects take longer. You really do have to start developing the time management skills now. Don't put things off. It's very tempting. As a former student, I know this. Oh, that assignment's not due for another month. I'm going to think about it in 27 days or so. But in industry as well, time management is a problem. Just look at how many video games and pieces of software get delayed every single year. That's because people don't manage time well and don't estimate how much time it's actually going to take to complete a task. So I think learning time management is the number one thing that's going to help you both now in school and when you get out into the real world. Because in technology, missed deadlines and pushing projects, yeah, that's a real thing. That's a real problem. If you can avoid it at all, it's certainly ideal. So time management, number one thing.
Good advice. Good advice. Does anyone have a question or a comment they'd like to make? I'll wait the requisite 7 seconds. You can either unmute or throw something in chat.
Oh, okay, yeah. So here's a question from Kyle. Doing all that with responsibility and family and whatnot, how did you manage your time and some pointers you can provide? So much going on, afraid to think about furthering degrees. The child, oh, yeah, Kyle, for sure. I have 4 children between the ages of 15 and 3. So again, the time management is going to be kind of the number one thing. Make sure that you plan things out and then you have to stick to it. That's kind of the hard thing is, there's been lots of times where I'll be, doing on schoolwork and, I want to do something with the kids or other sorts of things. You really do need to kind of stick to your plan to make sure that you can keep up with the work. And kind of on the flip side of that, I do say, make sure that there's time for other things as well. I probably shouldn't say this, but most of the time, people don't care if you get straight A's in graduate school. I've talked to a number of adult ed students, teaching and some of my classmates, and getting B's when you've got all these other things going on is okay. So don't always go into the mindset of you have to get 100% on everything. It's going to be a balancing act like it's going to be with everything else. I probably shouldn't say don't strive for an A all the time, but and keeping your eyes on the ultimate goal. It's satisfying to be done. You'll be in a position to support yourself and your family and fulfill your vocation. So hopefully that helps. You won't be able to fully imagine what it's like until you get into it. I mean, I couldn't either. It's going to be unexpected and there's going to be ups and downs, but it's something that you can do. People have done it. You can do it for sure. Ryan, did I take this class as a student at CEW? Yes, I took software engineering. We called it CSC 370, but yeah, we had. I still remember the project that my team created. We created a financial calculator for calculating mortgage payments. A little bit more impressive in 2001 than it is today, but it was a good experience. working as part of a team, I think, is the most important thing you can take from software engineering. Uh, Working with other people, not being able to do everything yourself. We all complain about group projects in school, but in the real world, you're not going to be able to do everything yourself. You're going to have to delegate. You're going to have to work with other people. You're going to have to allow them to fulfill their roles and communicate with them effectively. So yeah, absolutely. I think that's the number one thing to take away. Online schooling is the best route for flexibility. For flexibility, because you qualified it that way, I would say yes, absolutely. What I tell people about online school is it's always, I think, a better educational experience if you can do things in person, in the classroom. The last couple of years have just reinforced this for me. There is no substitute for face-to-face interaction in education. Now, that being said, I did my master's and my doctorate almost entirely online. The key for that is for you as a student to be motivated, self motivated, committed to the work. It's much easier in an online course to kind of, slack off. It's harder for the professor to notice and kind of catch that and pull you aside, be like, hey, what you doing? You got to keep up with this. It's easier for you to kind of slack off. But if you can maintain that level of motivation, then absolutely, I think online is a good way to go.
Good. Anything else?
So you mentioned that like graduate school isn't necessary all the time, and I was wondering, one of the computer science professors here, Professor Tallman at Concordia, he mentioned to me that I can take graduate school supported by the company because the company pays me, and so I was very interested in that opportunity. And do you think that is a like a must-have thing to grab, or is that still on the optional side?
If your company is going to pay for you to do a graduate degree, if there's any possible way for you to do it, you should do it, because, well, somebody else is paying for it. But then you have that value. It'll be beneficial to you. And yeah, I would say absolutely. It's in some circles that's a little bit less common now. But yeah, if your company's going to give you that as a benefit, I would go for it. It's going to be a good experience either way, and then you have that flexibility in the future, and you didn't have to take out a bunch of student loans for it. So yeah, absolutely, I'd go for it.
Yeah, Andrew, that's a good question. When I worked at Hewlett Packard, they paid for my graduate program, and that's really why I did it, because they saw value in it. And what Josh is saying is, we find a lot of employers right now don't see a whole lot of value in a graduate education, especially if you are a software engineer or programmer. But I would second what was said. Anything else? Questions or comments? All right, good enough. Well, Dr. Josh Locklear, it's weird when the father calls his son Dr. Locklear. Well, anyway, we're going to do. Thanks so much, Josh, for joining us. I appreciate it. And we're going to let you go now and take care of your kids.
Yeah, thanks. That's my pleasure. Nice to virtually talk to all you guys, and we'll see you around.
All right. Thanks, everybody, for allowing us to do that. I think that there are some important things you can get out of hearing other people's perspective in that. I'm going to throw up, I forgot to do this after Dr. Littman spoke last time, but I'm going to open up a poll here that I think I have it set such that I wanted to ask just the question, did you find the guest presentations interesting and or useful and or informative? But that was all too long to put in the poll question. So you've got 5 choices. Do you find the presentation interesting, useful, informative, all the above, or none of the above? So if you take a moment and do this, and remember, these polls are anonymous and it doesn't matter. I just would like to get a sense, is it worthwhile to do this kind of thing? So go ahead and take a look at that right now. While you're doing that, we will take a break in a moment, because we do need to stand up, right? While you're doing that, I would just review some of the assignment issues. Today, assignments 22 and 23 are due. This is Sprint 2, dealing with the documentation and the actual project itself. And I've talked to some folks, and yeah, I'm not sticking to a hard and fast, is it got to be today? What if it's tomorrow? What if it's 2 days from now? That's okay. But at a certain point in time, we do run out of a semester here. So for those teams that actually have something and submitted, good for you. If you're still trying to button some things up and work with some things, that's okay. That's not a problem, at least right now. The next CNCS assignment, talking about the 10th commandment we started last time, we'll finish up today. That'll be due next time. But thinking ahead, and the reason why we don't want to push Sprint 2 off too far is Sprint 3 is due 2 weeks from today. That's in the midst of finals week for us. I'll say more about that and more about our third exam in just a moment. Okay, good. So folks, why don't you stand up, take a break. We'll stand up for a minute. And if you haven't done the poll, then go ahead and do that. We'll see what the results are. Stand up. You didn't go away, did you? Good. Be back. All righty. Thank you for taking the time to answer the question. I appreciate that. You're just also polite. Nobody would say that it was horrible, so I do appreciate that. I always like to have former students involved with this also, but we just had such a horrible time trying to schedule. And I thought too late, well, why don't I just have them record something and share it that way? But I apologize. Okay, onward. You heard both last time Dr. Lippman and today Dr. Josh Locklear talk about what are sometimes called soft skills, another term, emotional intelligence, or my term, professionalism. And these kinds of things are very important. Employers look at your hard skills. The hard skills are your technical knowledge and abilities. Can you really create a linked list and do an insertion sort with it in some programming language? As a programmer or a software engineer, that's going to be expected. And employers want to know that you can do that. Your degree and the grades that you get in the courses in your degree program are good evidence of that. But what about these other things, professionalism, or what many people call soft skills? Well, here's where that networking comes in. And this is what really one of the main purposes of an interview. When I hired people, I looked at lots and lots and lots of resumes all the time. And to get your foot in the door, you had to have computer science degree and a certain GPA and whatever. But then really, we looked at the interview process of how do you carry yourself? How can you communicate? Can you articulate? Yeah, it's a little bit of a can you solve problems on the spur of the moment? But it's not so much that you solved the problem and could explain it to somebody else, but really the manner in which you did those things. So if nothing else, here are some aspects of professionalism that you can just carry along with you. And we're up to number 10, being helpful. Tenth commandment, you shall not covet all those other things beyond your neighbor's house, your wife, servants. I don't think that happens anymore. Animals. But in context, we could update these things, right? Or anything that belongs to your neighbor. Now, how did Luther explain that? Tia Carmen's Old World Wisdom. To achieve happiness, be content with what you have. Just be sure you have everything you want. Okay. All right. Maybe that's not exactly how it works. Luther said we should fear and love God so we do not entice or force away our neighbor's wife, workers, or animals. Note, or turn them against him. So it's not coveting just in the sense, I want that, I'm going to get it. But somehow, well, if I can't have it, neither can you. And then the positive aspect, as we've seen in every other commandment, urge them to stay and do their duty. Updating this to the 21st century with computer science, can our applications help our neighbor stay and do his duty? His duty being a shopkeeper or Sony Entertainment with their warehousing system or whatever it might be. And the answer, of course, is yeah, it can, to be sure. Oops. Oh, come on. How'd that happen? Can you see my screen? I'll stop sharing the poll, then maybe we can all see what's happening here. Good. Being helpful is sometimes really nice. This happened before you were born, and you may not know this story. You might find this story interesting. At the end of the 20th century, in the 1990s, Apple Computer Company was falling upon hard times. It really looked in 1997, I think I have the year correct, that Apple was going to go belly up, believe it or not. And then Apple received some assistance from what you were going to consider a very unexpected source. This is Macworld Expo. I think the year is 1997. We'll check it in a second. And shown on the screen here, I don't know if you recognize who that is. That's Bill Gates. Here's Steve Jobs on this new technology that very few people had in 1997, a cellular telephone. Bill, thank you. The world's a better place. Why? Because Microsoft pumped $150 million into Apple. What's it? Yeah, 1997. Wow, that was pretty helpful. You may wonder, what did Microsoft get? That Microsoft got some things out of it, but this was really not only the fiscal push, but also then this sort of confirmation from the big gorilla on the block, Microsoft, that Apple was a contender, to be sure. Interesting. Do you find any of these error messages helpful? There's another one that I encountered recently, and I forgot to grab it. It was just hilarious. Yeah, okay, these are pretty funny. An error occurred. No. Okay. An error occurred. No. Every time I copy something in Blackboard, the package has been processed. Warning, warning. The operation import has completed. Warning, it worked. Okay, I guess because we're so used to it not working, what's the deal there? I apologize that I've shown this one before. It's my favorite one. I know for some reason this happens to me all the time when I'm doing something, is setting up something in Blackboard. Error, error, and then a pop-up error. Error. That's not very helpful. All right. So being helpful is the aspect of a professional. We're in the midst of chatting about the 6th of 6 phases in the software development lifecycle, the maintenance phase. Let's just review the definition that we gave of it, and then we'll pick it up. Definition of maintenance: any change to the product. Don't forget, in software engineering, a product is not just the code. We're not just talking about the software. Code and documentation. That's documentation as comments in the code, but also those other documents, like the design document. Any change to the product after the product has been deployed. So once that product has been handed over to the client or user, once it's been put into production to solve actual problems, now the change is the maintenance phase. Last time we talked about 1, 2, and 3. So let's begin with number 4. Yeah, good idea. Regression testing. What in the world is regression testing? Regression testing is retesting. Retesting to ensure the correctness of the changes. Now, we already have tested multiple times in multiple ways throughout the first 5 phases of the software development lifecycle. Don't forget that in modern software engineering, you don't just test at the end of instantiation. You don't just test after you've created the code. You do test then, but you test at other steps also. And you test at the beginning, middle, and end of coding also. So we've already tested things once. Why would I have to retest during maintenance? Because we've made a change. We've actually changed the product. So in order to have confidence in our changes, we're going to have to retest to ensure the correctness of these changes. I think it makes sense. If we couldn't create it initially perfectly, why would we believe that we can make changes to the product perfectly without going back to verify those changes through testing? Regression test, test again. Re-execute all the tests. That test plan that we chatted about just briefly, I know we didn't have enough time to really get in depth in that, did we? But that test plan that we created in specifications, in design, and then finally fleshed out and did during instantiation, we want to go back to that and re-execute all the tests. You're saying, well, why should I redo all the tests? I only changed this module. Why do I have to check everything? If you don't know why, you haven't done enough coding yet. Do I mention it now or do I have to? Yeah. Code is extremely complex. I'll say a little bit later that a computer is a state machine. One thing in one aspect of the code can have far-reaching effects. So don't say, well, all I changed was the sort routine. I don't have to now change routine X, Y, or Z. No, we do. This is why today companies that do software development for a living automate the testing process. During initial instantiation, before initial deployment, they'll create the tests, but they'll create it in an automated environment. That way, if they need to retest, it's automated. What are the odds that they're going to have to retest? Very high. What percentage of commercial apps have errors? 100%. What are the odds that you're going to have to do maintenance on a project? 100%. Exactly. During the design phase predominantly, and also during instantiation, we talked about QA, quality assurance. So don't forget about this idea. Quality encompasses truth, and for us, that means accuracy. If the app is supposed to add numbers, it actually adds numbers correctly. It's truth. That's not the only aspect of quality. Beauty, not only of the internal code for other programmers to understand, but also of the external, the user experience. Is it helpful? Goodness. Is the code robust? Is the code fast and efficient? If it takes our app 39 seconds to add 2 numbers, I don't know of anybody who's going to say that's good. But look, it did add the numbers. Yeah, that's not a quality product. And then community, do we draw in our users? Initially, did we work with the users to understand their problem, to create good specifications, to create a good user experience? And does the app draw people in such that they want to use it? Those are all aspects of a quality product, something to think about in software engineering. So 2 terms that we've talked about before with testing, but I just want to review them now. The 2 terms associated with testing are, first of all, verification. Verification is something we do at the end of a phase. Are we building the thing right? That's terrible grammar, but it's alliteration. Are we building the thing correctly? We said we created an app to add numbers. Did we really? Let's verify. Let's run some code tests and see what it does. But there's another aspect of testing, sometimes forgotten. Validation. Validation happens at the beginning of any phase. And we ask ourselves the question, are we building the right thing? At the beginning of design, how would I know if I'm designing the right thing? I go back to the specifications, review the specs, be sure I understand the specs, and use that as the foundation for design. At the beginning of instantiation, the beginning of coding, go back to the design, read the design. What are the features? What are the functions? How are the algorithms implemented? How are the data structures implemented? And then we're probably doing a pretty good job. Testing, a lot of management, like everything else in the software engineering process. And by way of review again, who should do this testing? Well, we saw before there can be a couple different ways to slice and dice this. We could have internal testers, and hopefully every company that produces software has internal or what we call alpha testers. Those internal testers might be the developers themselves. The same folks who instantiated the code might be called upon to test the code. An alternative is we might have a separate organization or a different group, maybe it's even called quality assurance, that does the testing. In addition, it's always valuable to have external testers, beta testers. The problem is, if you've seen this before, what most companies call beta testing, they're not really doing, they're just throwing out a pre-release product, hoping you'll hack on it enough, and it's not really beta testing. Beta testing is an external organization that understands how to test products, has the specifications, maybe even has insight to the code, and can do well the white and black box testing that's really necessary to exercise the product. Internal testers, external testers, both valuable and and useful. Hey, more review. We talked about this before, but it happened before during instantiation. It's also going to happen now during maintenance. An error is uncovered. The user uncovers an error. There's two things we got to do. When an error is uncovered, we have to make two determinations. How severe is the error? And what is the priority? How bad is it? How soon are we going to take care of it? Those are sometimes related, but not necessarily. You may not correct all errors. Apple chooses to do this all the time. There are plenty of errors in every and any Apple product. If you use a mobile device and you immediately updated to iOS 16, you very likely experienced a number of the errors that were there. They were pretty glaring. But sometimes it's just a fact of life. A company's not going to correct all errors. Whether the error is critical, serious, moderate, or trivial. I grew up in a world where we had 4 severity levels of bugs. Many companies and people today just talk about 3. That's okay. We just rank them somehow, right? We have to determine how bad they are. Critical errors cause the system to drop dead or lose data. Serious errors cause truth errors. Oops, we didn't get the right answer all the time. You're probably going to miss these puns. I'm sure you are. Zeb, I sent my baby off to the army. See, what? Well, what happened? Oh, they put him in the infantry. They put him in the infantry. They put him in. You're pretending not to like them. It's okay. I understand. I understand. This is review also because we talked about it during instantiation. So you test, you find an error. Remember, testing does not improve the product. You say, but then I'm going to make change. Well, that's something different. Those changes, that's debugging. Debugging is not testing. It is something very different. To debug means the following: to correct errors in the code without introducing new errors. Ay, ay, ay. If we couldn't create the code perfectly to begin with, why would we think our changes to the code are perfect? Do you know how common this is? Answer, very. Debugging oftentimes introduces new errors. Whew, this is hard. Oh, don't forget, what's a software product? If you're debugging, you're going to change the code, I assume, and perhaps you also have to change the documentation. If there was a logic error in the code, there was a logic error in your design. The design needs to change. Maybe there was a specifications error. You'll have to go back and change that also. Changing the code without changing the documentation is the root of all kinds of evil, because now the next team that comes along to maintain this code, they're going to read the documentation first to try to understand it. And it's not going to match the code. And let me tell you, that's really frustrating. I'm going to jump in here for just a minute. Did I ever share with you I really believe that you can find the answer to almost any computer science skill-specific technical question at the Microsoft website somewhere. The only problem is trying to find it. Did you know that Visual Studio has very powerful built-in debugging tools? That's another semester to learn them. What is debugging? Well, first look at the debugger. How about just in general? What is debugging? Visual Studio Debugger is a powerful tool. Before we show how to use it, we want to talk about some concepts. Yeah, need those too. Debugger versus debugging. Debugging can mean a lot of different things, but most literally, it means removing bugs from your code. Now, there are a lot of ways to do this. For example, you might debug by scanning your code, looking for typos, or by using a code analyzer. You might debug by using a performance profiler, or you might debug by using a debugger. Specialized development tool that attaches to your running app allows you to inspect your code as it is running. Yeah, very powerful idea. How to debug for absolute beginners. Without fail, the code we write doesn't always do what we expect it to do. Sometimes it does something completely different. When this happens, the next task is to figure out why. We might be tempted just to keep staring at our code for hours. It's much easier and efficient to use a debugging tool or a debugger. Isn't something that can magically reveal all the problems. It's not something that you run and says, hey, here on line 13, you got a problem. No, it's an amplifying tool. It allows you to amplify your own brain power by inspecting various aspects of the code and saying, wait a minute, why is that variable -12? Where'd that come from? Using a debugger effectively is also a skill. It takes time and practice to learn, but ultimately a fundamental task for every software developer. Yeah. Okay, I told you you'd miss these. So, hey Zeke, what's the difference between a hippo and a zippo? I don't know. What? Oh, one is really heavy and the other is a little lighter. Little lighter. He's just going to keep doing this until you laugh. One is really heavy. The other is... A lot of talk recently among software developers and software development, thank you, about a technique called defensive programming. We couldn't even really do debugging. We can't do this, but again, it's something else you should have heard of. You consider this. Just like defensive driving, defensive programming is coding under a worst case scenario. Defensive driving, you're thinking about, what if the, I almost said idiot in the next lane. That's not civil. What if the individual in the next lane suddenly pulls into, you're thinking, where's my escape route? Where's my backup plan? How much room, and those, you're driving under worst case scenarios, hoping they don't happen, hoping that dump truck doesn't really pull out in front of you. But if it happens, you're prepared. Same thing in defensive programming. We think, what could go wrong? And what can I do as a developer to plan for that and mitigate it? Is there a way to prevent future errors rather than just fixing them when they come up? Defensive programming. So at least now in the job interview, when they throw out that term, you know what it is. Nobody's expecting you to actually have done this. This is deep stuff. What are some complications in the world of debugging? Where is the bug? When you execute a test, you discover that the answer is incorrect. But the real question is, where in the code did we get this incorrect answer? I doubt you think that, well, the bug must be in the print statement because that's when it showed up. It said it was -12 when we know full well the answer was 23. Probably really wasn't in the print statement, even though that's when we saw it. And I'm sure you've done enough coding to realize that oftentimes the error isn't where we expect it or thought it might be. Trying to track down the exact, by location here, I'd like to say just one statement, but it might not be a single statement. Which statement is wrong? Which line of my code is incorrect? That's not easy to determine. Sometimes it's very difficult to reproduce the bug. If the user sends you a message and says, look, I just got a wrong answer, and you execute the code, you get the right answer. Well, you could assume the user doesn't know what they're talking about, but it'd be better to say, I probably didn't do the same conditions that the user did. Reproducing errors is also hard. And oftentimes bugs have unexpected consequences. It didn't just mean that the output answer was wrong. Something else happened too. All right, now we're going to end there because we've pumped through a lot of stuff. Let me share with you, I'm going to hang around for a while. You got a specific question, your team has a question, happy to take those now. Or feel free to send me a message. Again, if I'm not responding quickly enough to the CUI email, then send it to locklear@cuw.edu. I'll see that quicker, and I'd be happy to answer these questions. Just thinking ahead now. We don't have a final exam in CSC 222, but we do have a third unit exam. That exam will happen during the final exam schedule for this course. And if I'm reading Irvine's final exam schedule correctly, the final exam for this course is scheduled for Monday, not this coming Monday, Monday, December 12th at 3 p.m. What's going to happen, by the way, is just as before, the exam be just like the first two, same length, same format, just different questions because it's on Unit 3. But that exam will open up on the morning of December 12th. Feel free to take it whatever time is convenient for you. If you can, I'd encourage you to set aside the final exam period to do it. You don't need 2 hours. It's a 40-minute exam as the other ones. Or you could take it up through the end of the day on Monday. I'll say that again next week, but our exam 3, Monday, December 12th. Sprint 3 is going to be due after that. Yeah, I'm sorry. I know there's other things going on during final exam week, including some people would really probably like to leave early, but you may do so if you have the sprint done. Otherwise, it's due Wednesday, December 14th, sprint 3. No documentation needed on that one. That will be the final project. All right. Folks, thanks so much for your rapt attention. I appreciate it. I'm going to hang around after I stop the recording here to answer any questions you might have. Thanks for being here. Have a nice day. Work hard. I'll see you next Monday.